Greetings, hello, welcome to another video about rational functions. We have already seen some examples of rational functions. We have sketched a few of them, and we have already defined what rational functions are. Just a quick recap. Rational functions are ratios of polynomials. As you can see here, if it's a ratio, it has a denominator and it also has it has a numerator. This is the numerator and a denominator. The numerator is a polynomial, as you can see here, and the denominator is also a polynomial. Okay, that's just about it when it comes to recap on rational functions. They're just ratios of polynomials. With that said, let's plot a few. Okay, let's plot this one. Plot example 1. Alright, example 1, h of x 2x plus 1 over x plus 1. Okay, the first thing that we need to look at before plotting or sketching is the zeros of the denominator. Okay, so the reason being, because at the zeros of the denominator, that's where our vertical asymptote is located. That's where you find the location of your vertical asymptote. To find the zero, you just equate the denominator to 1 and solve for x. Equate it to 0 and solve for x. So in this case, x is equals to, remove x to the other side of the equal sign, that will be minus 1. So x is equals to minus 1 is 0 of the denominator. Therefore, our vertical asymptote lies at x is equals to minus 1. Alright, horizontal asymptote. The horizontal asymptote, we compare the degree of the polynomial. We look at the numerator and the denominator, and we compare the degree of the polynomials. Seeing that in this case, the numerator and the denominator are of the same degree, we just divide the coefficients of the variables with the highest degree. So in this case, when I say degree, I mean order, with the highest degree order. So in this case, we have 2 divided by 1 numerator over denominator's coefficient, which is 2. So we have the horizontal asymptote at 2. Other points that we need to find: the X-intercept. We find the X-intercept when y is 0. So to solve for that, h of x, we replace it with y. We equate the entire equation to 0, so it will be 0 is equals to 2x plus 1 over x plus 1. So we multiply by x plus 1, multiply that side by x plus 1, and multiplied by 0 becomes 0. X plus 1 and x plus 1 cancel each other out, so we only left 2x plus 1. Then minus 1, also plus minus 1. So we have negative 1 is equals to 2x plus 0. Therefore, divide by 2, and we end up finding that our x is equals to 2 and 2 is 1. It was the negative 1 over 2. So x is negative 1 over 2, which is the same thing as negative 0.5 as our x-intercept. So at minus 1 over 2, the graph will intersect the x-axis. Let's find the y-intercept. Y-intercept is found when we replace x by 0. Okay, so that will plus x by 0, y is equals to 2 multiplied by 0 plus 1 divided by 0 plus 1. Okay, 1 over 1. So when x is 0, y is 1. Cool. Nice. Okay. Now that we have this point, we can go on and plot our graph. Plot it this side. Okay. Alright. Let's think we can do better maybe. Can do better, come on. Okay. Okay, let's just draw this. Let's look at Cartesian coordinate. This is x and this is y. Vertical asymptote at minus 1. So the minus 1 is on the negative side, so this is obviously goes all the way to infinity, though it's positive infinity to infinity, all the way to negative infinity. Okay, so that's negative 1. What other points do we know? The horizontal asymptote is at 2. Okay, is located at y is equals to 2. Okay, put it somewhere there. 2. Right. Cool. Okay, we have our asymptotes plotted. Now we need to look at our x-intercept. So when y is 0, x is minus 0.5. Okay, minus 0.5 is somewhere here. X-intercept. Okay. So this tells that this graph will be in this direction, but let's just see if it's so. So from here I can already see that the graph would look something like this, but let's just move or follow where the math takes us, where the points take us. Okay, Y-intercept. So Y-intercept when x is 0, when x is 0, Y-intercept is 1. So Y-intercept is right there. So from here, right from here, we can already see the graph. Graph should always approach the drawn asymptotes. So these 2 points are just telling us the graph is in this direction. So the graphs should always approach your asymptotes as the asymptotes approach infinity. Can be positive infinity or minus infinity. So a graph and reflection of this graph. Okay, so where's the other portion? In which region do we draw the other portion of the graph? That's okay. Let's find out how the graph looks like at this side of the asymptote. Minus 2, minus 3. Okay. Okay, cool. Let's do that. Okay, so when x is minus 2, what is the value of y? Okay, 2 minus 2 plus 1 divided by minus 2 plus 1. Okay, 2 by minus 2, that's minus 4 plus 1 divided by minus 2 plus 1 minus 1. There's minus 3 over minus 1, it gives me 3. Okay, so if x is minus 2, the graph is 3. 3 will be somewhere there. So this is our point. Okay, what if x was minus 3? Let's see, what will be y? X is minus 3. It's 1 over minus 3 plus 1. 2 by minus 3, that's minus 6 plus 1 over minus 3. Minus 3 plus 1, that is what? Well, that is minus 2. Negative 2. So negative 6 plus 1, that is minus 5 over minus 2. 5 divided by 2, that is 2.5. So 5 over 2, 2.5. 2.5 is in between 3 and 2. So somewhere there. This is telling us the graph is going in that direction. Cool. So already from here you can say that the graph would go like that. Yeah. So okay, so graph will look something like that. Okay, so what's the domain of the graph? The domain would be all the values of x except and x is equals to -1. And that's the domain, which we can also write as minus infinity to -1 union -1 positive infinity. Okay, what about the range? The range will also be all the values of y except for y is equals to 2, or we can write it as range minus infinity to 2, from minus infinity to union to the positive infinity. Okay. Okay. Cool. So that's how you plot the first one. Let's plot the second one. Okay. Let's plot the second rational function. Plus 2x squared over x squared minus 1. And now we see that the numerator and the denominators are all polynomial. Let's see if we can factor these polynomials. 2x squared is just 2x squared. There's nothing else we can do to that one. About x squared minus 1. I see that it's a difference of squares, 2 squares. So this is the same thing as x minus 1 multiplied by x plus 1. But this doesn't help us. So there's nothing that factors out. So it's, well, okay. This actually helps us to get the 0 of the numerator. So let's go ahead and plot it. Before plotting, we need the vertical asymptotes. And factoring it out like that definitely helps us big time to get the location of the vertical asymptotes. So vertical asymptotes, we equate the denominators to 0, we get the zeros. The location of the zeros tells us the location of the vertical asymptotes. Alright, x minus 1 plus, multiplied by x plus 1, equate it to 0. From here we get x minus 1 is equals to 0 divided by x plus 1. Everything is equals to 0. Therefore x minus 1 equals to 0. And from here we get x is equals to 1 as one of the zeros. And what else can we do? Yeah, x plus 1 is equals to 0 divided by x minus 1, everything equals to 0. Therefore x plus 1 is equals to 0. And finally x is equals to minus 1. So the zeros are x minus 1 and x is equals to 1. So from here we know that the vertical asymptote lies at x is equals to 1 and at x is equals to negative 1. Alright, cool. Alright, what else? Let's look at the horizontal asymptote. First question is, does our rational function have the horizontal asymptote? Well, let's look at the degrees of our polynomials, the numerator and the denominator. They are all of the degree order of 2, which means they are the same. Therefore, y, in other words, the location of our horizontal asymptote is located at 2 divided by 1. So that is this 2 divided by the 1 in front of x squared. So always when the order of the polynomials are the same, in other words, when the numerator and the denominator are of the same order, you just divide the coefficients of your highest order of the two polynomials. In this case, your numerator over your denominator's coefficient. 2. Cool. There's another case, however, and that is, let's say, for example, what if, let's say f of x, let's say 2x squared, and the denominator was of a higher order, the power 3 minus 1. In this case, our horizontal asymptote will be at y is equals to 0. Always when the denominator is of a higher order than the numerator, then your horizontal asymptote is located at the origin, y is equals to 0. The other way around, what if the numerator was of a higher order, let's say the power 4 x to the power 3 minus 1. Well, in this case, we will not have a horizontal asymptote. Instead, we'll have an oblique or slanted asymptote. Okay. Alright, cool. Hope that is clear. Okay, so let's get our X-intercept. Okay, X-intercept. So X-intercept is found when y is 0. Okay, so when y is 0, so we just equate the entire function, the entire rational function to 0. 0 is equals to 2x squared over x squared minus 1. Therefore, this multiply everything by x squared. What am I doing? Yes. Multiply both sides of the equation by x squared minus 1. multiply there by squared minus 1. This becomes 0. That one and that one is 1. So in the end, we have 0 is equals to 2x squared multiplied by 1, which is the same thing. Therefore, x is equals to square root of 0, which is 0. So x is 0. So x-intercept is at the origin. Cool. Okay. Come on, let's go. Let's get the y-intercept now. So y-intercept we would say is found when x is 0. So what is y when x is 0? So what is f of x, which is the same thing as our vertical axis, or our y? What is y when x is 0? Well, see that 0 raised to the power 2 and 0 squared minus 1. So this is 0 divided by negative 1, therefore 0, so y is also 0. So let's get plotting. Oh no, what's going on with the graph? It's me. Let's get plotting. Oh, I need to do this right, at least. Okay, that's much better. That's better. Yes, nice. Alright, so we have vertical asymptote at 1 and negative 1. So at 1, and at negative 1, there is vertical asymptote. We have two vertical asymptotes here. That makes sense, it's a quadratic equation after all. Okay, x-intercept. I'll tell that x-intercept it is 0, 0, it's exactly at the origin. Same story for the y-intercept, is also at the origin. So x and y-intercept are at the same point, right at the origin. Okay, but we skipped one thing. Where is our horizontal asymptote? It's at 2. Horizontal asymptote is at 2, so let's plot it at 2. So it will be somewhere there. Minus infinity, positive infinity, all the way to positive infinity, and all the way to negative infinity. Okay, now I'm left with a question. Where's my graph? Is it here, or is it located there, or is it located there? Is it here? Is it there? Or is it there? Answer to that is I don't know. The only way I can know is by testing out some points that are on that side of the asymptote. So need a few points, sets of points to test out. We get some points in these regions, and then we test them out in the equation and see the behavior of the graph in that area or in that region, and then that behavior will tell us whether the graph is in the region or not. Okay, so let's get some points this side. So this is 1, so we'll make this one 2, make this one 3, then 4, 1, this one is 1.5, what am I doing, 0.5, so 0.5, this is negative 0.5, negative 0.5, then minus 2, minus 3, and see what our values for y are. Okay, so let's test it out. So what is f of x or y when x is 2? Going by 2 squared minus 1. Okay, 2 multiplied by 4, because 2 squared is 4, and 4 minus 1. Add all over 4 minus 1, that is 3. Over 3, so 1/3 of 8. Okay, over 3, what is 8 over 3? Well, 8 over 3, that means 3 go and add 2 times. How many times does 3 go into 8? Goes into 8 2 times and leaves a remainder of 2 over 3. So 2 over 3 is 2 over 3. What is 2 over 3? Well, 2 over 3 is the same thing as 20 over 3, but not, okay, I'm just working this out now. 20 over 3, what is 20 over 3? 3 goes in there. Okay, 3 times 4, that's 12, 5, that's 15, 6, that's 18, so remainder 2 again, so 2.6. 6, let me just round it off to 7. Okay, so it's 2.66666. 2.67. Okay, leave it there, so that's 2.67. So when x is 2, the graph is 2.67. This is 2 here, this is 2, horizontal asymptote, so 2.67 will be somewhere there, let's say somewhere there. So this tells us that the graph is in that region. So cool. Okay, so cool. Let's look at another point. Obviously 3 will be somewhere there, somewhere there. Okay, that's why at 1 it goes all the way to infinity. So this tells us that our graph, oh boy, come on, oh buddy, our graph would be like this. Okay, so that's one portion of the graph that we have found out. Okay, what is the behavior of the graph in this region between -1 and 1? How does the graph behave in this region? Okay, we'll look at this region later. Let's look at what is the behavior on this side. What is the behavior of our graph on this side? Okay, cool. So what is f of x where x is -2? 2 by 4, 4 minus 1, add by 3. Add over 3. 2.67. Oh, it's an even graph. Already from here I'm starting to say that this is an even, yeah, it's an even function. So 2.67, so we can already see from here that it would exactly be similar to that. It's a reflection in the y-axis of that graph. Let's put one more point, maybe 2. Okay, what if -3 squared minus 1 comes squared. 2 into 9, or 2 by 9, 9 minus 1, this is 18 over 8. Okay, tells us 18 over 8, 10 divided by 8. Alright, can simplify this one. Alright, 2 and 8 is 4, 2 and 18, that is 9. 9 over 4, 9 over 4, okay, 9 divided by 2, this is 4.5, 4.5 divided by 2, that gives me 2.25. So this is 2.25. Okay, cool. 2.25. That is lower than 2.67. So 2.25 is right here. 0.25. You can see that the graph is approaching the horizontal asymptote as x approaches infinity. So this is how a graph will look like. Okay, so the graph is that side. Okay, so what is the behavior of the graph in the region between -1 and 1, or in between the vertical asymptote? What is the behavior? You know that the graph is X-intercept and Y-intercept at 0, 0. So what if X was 1/2 or 0.5? Okay, well, let's find out. If X was 0.5, it will be 2 multiplied by 1/2 squared divided by 1/2 squared minus 1. Okay, this will be 2 multiplied by 1/4 divided by 1/4 multiplied by 1. 2 into 1/4, that is what? 2 is 1, 2 that is 2, so that's 1/2. 1/2 divided by 1/4 minus 1. Just do that here. 1/4 minus 1, 1, 4, 1 minus 4, 1 minus 4 to 1 minus 4, that is minus 3 or -3/4. So this is -3/4. What are we having here? We have 1/2 divided by -3/4. Let's just reciprocal that, it becomes -4/3. So finally we have 1 multiplied by -4. Oh, let's just simplify. 2 is 1, 2 that's 2, so 1 by 2, it's 2/3, so -2/3. This is -0.66667. This is -0.67. Okay, it's an even function, so this will be the same answer that we'll get if x is what? If x is -1/2. Okay, it's -0.6. This is where -0.67 is. So when x is 1/2, that is my point there. And when x is -0.5, it's an even graph, so we'll have it that way. So from here, these 2 points can be able to tell the general behavioral pattern of our graph. It never touches the asymptote, so it will approach the asymptote as y approaches infinity. Okay. Something like this. Okay, that's slightly Okay, so yeah, that's how the graph will look like. So this then would be the graph of f of x, well, the rational sketch of the function 2x squared over x squared minus 1.